All right, welcome to the Explainer. Today we're going to talk about a tool that honestly totally changed the game for Java development and really redefined how we all build software, Apache Maven. Look, if you've ever worked on a software team, I mean any software team, you know this exact feeling. It's like trying to conduct an orchestra where everybody has a completely different sheet of music. It is just pure chaos. And before tools like Maven came along, this wasn't just an occasional headache, this was the daily grind. You'd have library files just going missing. Builds would mysteriously work on one person's computer, but fail on everyone else's. And getting a new developer set up, that was a painful manual process. It all came down to that one dreaded phrase that every developer hates to hear. But it works on my machine. So back in 2002, a developer named Jason Van Zyl basically said, enough is enough. He decided to take on this chaos directly. And the tool he created to do it? Apache Maven. So what was the secret sauce here? What was Maven's big idea that changed everything? Well, it all boils down to this really powerful philosophy: convention over configuration. And you have to understand, this was a massive shift in thinking. Instead of you having to spell out every single detail for the build tool, Maven just assumes a standard or conventional way of doing things. You only step in when you need to do something different, something special. And that simple idea, it saves developers an unbelievable amount of time and headaches.
Okay, here's a great way to really get the difference. Think about the old way, with tools like Apache Ant. You had to write this super detailed, step-by-step recipe for everything. Compiling, testing, packaging, you name it. But with Maven, you just declare what your project is. You don't tell it how to build it. Maven already knows how, thanks to its standard, predictable process. It just works. Okay, so if you're just declaring things, where do you actually do that? It all happens in one central file that's basically the blueprint for your entire project, the project object model, or as everyone calls it, the POM. Yeah, this one file, the pom.xml, is literally the heart and soul of every single Maven project. It's the source of truth that tells Maven everything it needs to know to get the job done. The very first thing you'll find in the POM are the project's coordinates, and they're exactly what they sound like. It's like a unique mailing address for your software in the vast universe of code. You've got the group ID for your company, the artifact ID for your project's name, and of course, the version. Put them together, and you have an unmistakable ID. All right, next up is maybe one of Maven's most loved, most powerful features, dependencies. Think of these as the ingredients for your project. You just list out the external libraries you need, like say the JUnit testing library you see here. You tell Maven what you need, and it handles the rest. No more hunting for files online. And this right here is convention over configuration in its purest form. Maven expects a standard folder layout. If you put your Java source code in src/main/java and your tests in src/tests/java, you never have to tell Maven where to find them. It just knows. It makes every Maven project on the planet feel familiar and easy to navigate. Okay, so we've seen the what, that's the POM file. Now let's pull back the curtain and look at the how. How does the magic actually work? It really comes down to two key things: dependencies and life cycles. And seriously, don't underestimate this part. It's a huge deal. If you ask any developer what they love most about Maven, I guarantee dependency management is going to be right at the top of the list. So here's how it works. Maven reads that dependency list in your POM, right? Then it goes out to this giant online library called the Maven Central Repository, finds the exact version of the library you asked for, and downloads it to a local cache on your machine. Done. But, and this is the really slick part, it doesn't stop there. It also automatically downloads the dependencies of your dependencies. This is called transitive dependency management. So if your project needs library A and library A needs library B, Maven just gets them both for you automatically. It's an absolute lifesaver. So the other half of this magic trick is what's called the build lifecycle. You can think of it as Maven's built-in instruction manual, right? A predefined sequence of steps or phases that every project follows to get built. Let's walk through the main phases. First up, compile. No surprise there, it compiles your code. Next, test. It runs all your unit tests to make sure nothing broke. Assuming that all passes, it moves to package, where it bundles up your compiled code into a file you can actually use, like a jar file. And finally, there's install.
This phase takes that package and puts it into your local repository so other projects you're working on can use it. And here is the absolute best part. You don't have to run these one by one. You just run a single command, like mvn install. And when you do that, Maven is smart enough to run every single phase in order, right up to install. One command to compile, test, package, and install your project. That is the power of a standardized lifecycle. You know, when you look back, Maven was so much more than just a build tool. It was a real game changer that left a huge, lasting mark on how we all develop software. I mean, this tool has been a pillar of the Java world for over 2 decades now. It all started back in 2002. By 2004, it had its first major release and started setting the standard. Then version 2 came along in 2005 with massive improvements, and version 3 in 2010 really kicked things into high gear with things like parallel builds. It's just been this incredibly stable, evolving foundation for developers for years and years. And you can really see its influence when you look at the tools developers live in every day. I'm talking about IDEs. All the big ones, Eclipse, IntelliJ, NetBeans, even VS Code. They all have Maven support baked right in. It's just there, ready to go. But maybe Maven's greatest legacy isn't what it does, but what it inspired. Its core ideas, that declarative dependency management, the standard life cycles, those concepts directly paved the way for the next generation of build tools. Things like Gradle and SBT, they stand on the shoulders of the principles that Maven established. It truly set the standard for everyone that followed. So at the end of the day, Maven brought order to chaos. It gave us a common language, a common structure for building software. But now our world is getting even more complex, right? We have containers, cloud-native architecture, the whole shebang. So it really makes you wonder, what's going to be the next tool, the next idea that standardizes it all for us again? Something to think about. Thanks for watching.